Hello viewers, you're welcome back to this channel. So here we'll be looking at trigonometry identities, and we'll be discussing how to simplify trigonometry expression and how to prove trigonometry identities. But first, we would like to differentiate between an equation and an identity. So if you look at this algebraic expression, x plus 2 equals to 5, this is an equation, but it is not an identity, because this is only true for some values of x. Yeah, so here, for example, this is only true when x is equals to what? When x is equals to 3. Also, this one, if you have this expression, look at this one. The second one is an identity, because what you have on the left-hand side is the same thing as what you have on the right-hand side for any values of x. So for example, if x is 0, they will be the same. If x is 1, they will be the same. For any x in a real number, these two expressions, the left-hand side is equals to the right-hand side. So we say it is an identity. But the first one is not an identity. It's just what? An equation, because it's only true when x is equals to 3. Now, if you look at this for the trigonometric identity here, sine squared t plus cos squared t is equals to 1. This is also true for all values of t. So these first two, they are identities. But even though the first one here, this is algebraic, and why this is what? It's trigonometry. So this, you can call it algebraic identity. And this is a trigonometry identity. Right. So let me just add an example here. For example, if you have an example, let's say sine x equals to what? 1. You see, this is not an identity because it's not true for all values of x. So here, this is only true for some certain values of x. For example, if x is equals to pi over 2, it's true. And for any, or some maybe like the coterminals as well. But it's not true for all values of x in the domain of sine. So this is not an identity, but it's what? It's an equation. All right, so if you look here, let's look at some identities. We have some identities we've discussed in previous sections. For example, the reciprocal identity, there are about 5 of them. So these are the reciprocal. Cosec x is 1 over sine x. Then we have the Pythagorean identities. We also have the even identities, even and odd identities. So sine is odd, cosine is odd, cosine is even, and tan is also odd. And we have the co-function identities as well. You can see there is a co-function identity between cosec and what? And sec. And yeah, so these are stuffs we discussed earlier. Now, let's just go into simplifying trigonometry expression. Now, what is the importance of identities? If you have identities, we can use identities to simplify trigonometry expression that looks very complicated. We can write them to become, we can simplify them. So let's take this example. Example 1 now. We have this trigonometry expression we want to simplify. So to simplify, we have to think of various identities, right? For example, here, we can start by, let me write it here. This is cosine t minus what? Tan minus t of sine t. So we can use the identity of what? The fact that tan is what? Is odd. So this minus can come out. So this becomes minus tan of what? Tan t, then sine t. So we've used the identity that tan is what? Is odd function, and this is true for any value of t. So this is cosine t minus minus becomes plus tan t, then multiply by sine t. Now, we've not really done much because the function we started with, or the expression we started with, and the one we stop here, there's no much difference in terms of the length of the function, or in terms of here you have in terms of the number of terms, right? So we can simply simplify again by using another identity, which is the reciprocal identity, because you can write sine tan t as sine t over cosine t, then multiply by sine of t, right? So with this, we have that cosine t plus, now sine and sine will become what? Will become sine square. So this is like saying sine squared t over what? Cosine t, right? But if we look clearly, we can try to write them to have the same denominator. So we can multiply this by what? We can multiply this by cosine t over cosine t. So with that, we will have cosine squared t plus sine squared t, everything over cosine t. Okay, now you see we can still use another identity with the reciprocal identity. Cosine squared t plus sine squared t, it's simply 1. So we have 1 over cosine t. And here as well, we can still use the reciprocal identity here. Yes. So here it's the Pythagorean's identity. Yes, cosine squared t plus sine squared t. Then from here, we can use the reciprocal identity, which is simply sec t. And the answer, it's A. All right, now for number 2, if you look at number 2, we can deal with the terms separately, or we can try to make the LCD. If you look at now, we can see what is be the LCD. It's just cosine theta, 1 plus what? 1 plus sine theta. So we can try to make that arrangement here. And we can achieve that by multiplying this by 1 plus sine theta over 1 plus sine theta, right? And also here, we can multiply the term by cos theta over cos theta. So here we have sine theta over cosine theta, and we have the plus, and here we can have this, it's okay, we can write it here. Multiplication is commutative. So this now, you see, this will just be 1 plus sine theta multiplying by sine theta plus cosine theta multiplied by cosine theta. Everything now we have the same denominator, 1 over sine theta cosine theta. Okay. So if we expand this will just become sine theta plus what? Sine squared theta plus cos squared theta over 1 plus sine theta and what? Cosine theta. So we can use now the Pythagoras identity. Sine squared theta plus cos squared theta is 1. So here becomes sine theta plus 1 over 1 plus sine theta cosine theta. And what does this mean? This we can rewrite it because addition is commutative. This is the same thing as 1 plus sine theta here over 1 plus sine theta multiplying by cosine theta. So this and this will still go. And then we are left with what? 1 over cosine theta, which is nothing but sec theta once again. So you see, we are able to simplify this expression because because of the presence of what? Of identities. So the good thing with identity is that they are true for all values of what? Of theta, so we can use them. All right, so we have another example here, example 3. So it's similar case, we can do the same thing. Our LCD here is just going to be the product of the denominator, 1 and this one. So we can multiply by the LCD. So here will be 1 minus. So here we just need to multiply this 1 plus what? Plus sine alpha. And also 1 plus sine alpha, which is 1. And this side we can multiply by 1 minus sine alpha over 1 minus sine alpha. So here we'll have 1 over 1 minus sine alpha, and then plus or multiply by 1 over 1 plus sine alpha. So if you look at this, we will have 1 plus sine alpha plus 1 minus sine alpha, everything over the product, which is 1 plus sine alpha, 1 minus sine alpha, right? So if we simplify, this and this will go. So we have 2, because this and this will cancel, sine alpha minus sine alpha. So we just have 2 over 1 plus sine alpha, 1 minus sine alpha. Now, if we look at this, the denominator is simply difference of 2 squares, which we can write as 1 minus sine squared alpha, right? And then we can use the identity. Remember, we know that cosine squared alpha plus sine squared alpha is equals to 1. Therefore, you have that what? Cosine squared alpha is simply 1 minus sine squared alpha. So this is going to be 2 over 1 minus this is just going to be cosine squared alpha, right? And what is 2 over cosine squared alpha? It's just 2, because we can write this as 2 over 1 times 1 over what? Cosine squared alpha, right? And once we establish that, we can see that our answer is just, let's just finish it here. This is just 2. 1 over cos squared alpha is what? Is sec squared alpha. Now, number 4. For number 4, it's also similar, but here, let's see what we can do. Here we want to simplify as well. So here there are many options. There are things you can do. You can try to make the denominators. You can make this to be the same, because this is 1 over 1. So we can write this as just 2 plus what's tan squared over what? Sec squared x minus sec squared x over what? Sec squared x. So this is just making denominator to be the same. So this will become 2 plus tan squared x minus sec squared x over what? Sec squared x. But in one of the identities, we know that 1 plus tan squared x is equals to what? Sec squared x. We know this, right? So what does that mean? It means that if you have tan squared x minus sec squared x, it's going to be minus 1, right? So it means that this is nothing but what? Minus 1. So this will become 2 plus minus 1 over sec squared x. And this is nothing but 1 over sec squared x, which is simply cos squared x. Then number 5. Number 5, also simplify the expression 1 plus what? Plus sine of u, right? So this also is similar to what we've done before. All we need to do is to use the what? The LCD. We can use LCD. Let's see. So what is the LCD in this case? It's just cosine of u multiplied by 1 plus sine of u. Therefore, we can multiply this by the first term by what? 1 plus sine. So 1 plus sine u over 1 plus sine u. And this also, we can multiply this second term by cosine u over cosine u. So here will be 1 plus sine u again over cosine u, and this will be cosine u over 1 plus sine of u. All right. So this we can expand. We can expand the numerator. This is 1 times 1. This is 1 plus, this will just be O. Another thing you can write, you can just write it as 1 sine u squared, right? Plus cosine squared u over the LCD, which is 1 plus sine u cosine of u. Then if you expand the numerator, this will just be 1 plus 2 sine u plus what? Plus sine squared u. So it's like using it's a plus b squared, right? So this is a squared plus what? 2ab plus b squared. So that is what we used here. So sine u all squared is the same thing as sine squared u. Then you still have plus cos squared u over 1 plus sine u cosine u. Now, these two terms will go to 1, right? So this will be 1 plus 2 sine u plus 1. This is 1 over 1 plus sine u, then cosine u. Now, 1 plus 1 is 2. So this will be 2 plus 2 sine u over 1 plus sine u, and then what? Cosine u. All right. So what can we do here? This we can simplify. We can take 2 as a common factor so that we have 2 into 1 plus sine of u over 1 plus sine u multiplied by what? Cosine of u. This and this will go. So we'll have just 2 over cosine of u. And what is 2 over cosine of u? This is the same thing as 2 sec u. All right. So that is that about proving, or we said simplifying algebraic expression. So in the next video, we'll be looking at how to prove identities. So thank you for watching.